Since this is a statistics class, we should start off with the definition of statistics. Statistics is the science of collecting, describing, and interpreting data. Before we talk about this definition anymore, we have to talk about what the word data means. So data is just a collection of information. That's a simple definition we can start with. We can say a collection of recorded information. Now what type of information do we care about in statistics? We don't actually care about information such as pages of information or paragraphs of information. What we actually care about are little pieces of information that people record. And the word data is actually plural. The singular version is data value, which is a piece of information that describes something about a person, animal, thing, or place. Let's give some examples of data values. Let's say I ask a person, how tall are you? And the person says, I'm 55 inches tall. That's the person's answer. So in this case, 55 inches is the data value. It's a piece of information that describes something about a person, animal, thing, or place. In this case, it's a piece of information that describes this person right here. So after we recorded this piece of information right here, we would say that this is a data value that we have recorded. What if we asked, well, we could do an example that doesn't have to do with people. Or maybe we'll do one more example with people. I say, what is your major? Maybe I'm talking to a college student. And the person says, I'm a psychology major. Now the word psychology, or well, if the person just says psychology, then we could say that psychology is a data value. This is a piece of information that describes something about this person. In this case, it describes the person's major. And if we were entering, let's say we asked 10 people, what's your major? And we entered them into a spreadsheet like Excel, which I'll show you how to do later. What we would have is a column of people's answers, and it would look something like maybe psychology, business, engineering, and it would just show the major of all 10 people all the way down. Each of those words would be a data value describing one person. What if we recorded the height of a tree? So I'll try to draw a tree. And we find out that the tree is, I'm not sure what the height would be. Let's say it's 98 inches tall. Now 98 inches is the data value that describes this tree. It describes the height of this tree. So in this case, 98 inches would be a data value. So we have three data values that we've looked at so far: 55 inches, psychology, and 98 inches. And sometimes people will ask me, what if we just wrote down 98 and didn't write down inches? Would 98 by itself be a data value? And it actually would be. You could say that 98 is the data value, and that, or you could say that 98 inches is the data value. It might just depend on how specific you want to be about the data value. So we talked about the meaning of a data value, and I said that data is plural for data value. So, and data value is singular and data is plural. So when we talk about data in this class, we're just talking about a collection of data values. More specifically, we're talking about a collection of recorded data values, such as a list of data values or a set of data values that have been recorded on a piece of paper or entered into a computer. Now that we know what data means, it's just a collection of data values, we can talk about what it means to collect, describe, and interpret data. Collecting data just means to seek out and record data. And the way you do that depends on the situation. If I want to know how tall a person is, I could ask the person, I could have the person fill out a survey, or I could just measure the person with a ruler. If I wanted to know a person's major in college, I could give them a survey, or I could ask them. But if I wanted to know the height of a tree, I obviously can't ask the tree. I would just have to measure the tree. So the way you collect data depends on the type of data you want to record. Describing data. Describing data just means, well, at least in this class, it means to summarize or condense data into a way that's easier to understand. So if well, two main ways of describing data that we'll talk about are calculating values that summarize a set of data and creating charts and graphs. So if I recorded the heights of 10 people and I calculated the average, meaning I added up the 10 heights and divided the total by 10, that would be, well, that average would summarize the entire data set of those 10 heights, and that would be an example of describing data because I'm summarizing the data set. If I asked 10 people, what's your major, and I calculated the percentage of people who told me that they're a psychology major, then that would be an example of describing data because I'm summarizing my data set. If I calculate percentages and I find out that out of the people that I surveyed, 30% were psychology majors, 50% were business majors, and maybe 20% were English majors, those percentages would summarize my data set. And you could say that the process of calculating those averages or those percentages would be an example of describing data. If you create bar charts or line charts, that's also describing data because you're summarizing the data set in a way that makes it easier for other people to understand. So interpreting data. Interpreting data means to just make sense out of the data and to find out what the data is actually telling you. When a person collects a data set, a person is trying to answer some type of question. A person is trying to learn something about the world that we live in. And when the person goes through the process of reaching a conclusion and actually deciding what the data set is telling the person, then that's interpreting data. For example, if I wanted to know if, let's say I wanted to know if people who spend more years in college actually end up making more money after they graduate, I could do a survey on that, and then I could ask a group of people, how many years did you spend in college, and how much money are you now making? And once I'm at the point where I actually reach my conclusion about whether it appears that going to college longer will help you make more money, I'm interpreting my data set because I'm reaching a conclusion. I'm actually trying to decide what the answer to my question is. So that's interpreting data. Another example could be, let's say I'm trying to figure out if people who, let's say I'm trying to figure out if students who are working are getting less, college students who are working are getting less sleep than college students who aren't working. So I want to find out if college students who are working are sleep deprived. So in that case, I would survey a group of a certain number of working students, and I would survey a certain number of non-working students, and I would ask each person, how much sleep do you usually get per night? And once I've recorded my data, I'll reach one of three conclusions. I'll either conclude that it appears that working students are getting less sleep than non-working students. I'll conclude that I might conclude that working students are getting maybe more sleep than non-working students, or maybe I'll conclude that there appears to be no difference in sleep between working and non-working students. I might conclude that I found no evidence for a difference in the amount of time or in the amount of sleep those two groups of people are getting. And any of those three conclusions might be possible. It's just the data that I collect will lead me to one of those three conclusions. So the conclusion that I make depends on what my data tells me. And that's interpreting data, reaching your your conclusion. So we've talked about the meaning of a data value. We've talked about the definition of statistics. Let's see what time we're at right now. Sorry about that. So let's talk about why a person would want to record data. We talked about that people want to learn about the world, but, well, people want to learn about the world and they want to be able to make decisions. And for example, a person might want to well, I'll restart this video in a second. In the last video, we covered some basic definitions. We talked about the definition of statistics, and we talked about the definition of data and the definition of data value. In this video, I wanted to talk about the purpose of collecting data. So what is the purpose of collecting data? The most simple answer would be that the purpose of collecting data is to learn about the world. But what are some more specific reasons for collecting data? We'll talk about three specific reasons for collecting data, and we won't cover all the technical details and all of the formulas that are involved, but we'll just give a brief overview of those three purposes of collecting data, and I'll try to give one or two examples of each one. one reason for collecting data is to make predictions. So we'll put prediction down here as one purpose of collecting data. Prediction involves using a known piece of information to predict an unknown piece of information. It might be a little bit too simple of a definition, but it works for right now. Predict an unknown piece of information. So what could be an example of this? A person who owns a business might want to predict next year's sales, but next year's sales is an unknown piece of information because the future hasn't happened yet, and the person right now, at this time, doesn't know what next year's sales will be. However, if the person has been keeping track of his or her sales this year, and the person has been recording their sales, then the person will know the amount of sales that they've made this year, or at the end of this year, they'll know what their total sales were for the year. So this year's sales would be a known piece of information, assuming the person kept track of it and recorded it, and the person could use this known piece of information, which is this year's sales, to make a prediction about what next year's sales will be, which is the unknown piece of information. And this won't be a perfect prediction, but the person will at least be able to use the known piece of information to get a rough idea of what the unknown piece of information will end up being. And in most cases, while most predictions aren't perfect, it's usually predictions are usually less than perfect when you use data to make predictions. You usually make a prediction that's not completely perfect, but is at least somewhat useful. Another example is estimation. Another purpose of collecting data is estimation. Estimation involves using data recorded from small groups of people or things to estimate, let's actually say using data recorded from a small group of people or things to estimate something about a larger group of people or things. And it might help if I give a couple of specific examples of estimation. One example is estimating the mean, which is the average. In this class, we'll talk about how a mean is an average. Of a large group of people. A person might be interested in what the average GPA of all college students in the US equals. And there's a lot of college students in the US. I'm not sure if this number is still correct, but last time I checked, there's 20,642,819 college students in the US. So if you actually wanted to know what the average GPA of all of those college students is, you would actually have to record the GPA of every college student in the US. Or you would have to find a person who already recorded the GPAs of all college students in the US, and you would have to find a person who could then give you that data set that they already recorded. But there's no guarantee that a person has already recorded all of those GPAs. So all college students in the US. So, if, like I said, if you actually wanted to be able to calculate the exact average GPA of all college students in the US, you would have to be able to record the GPA of all of these college students, meaning you would have to record 20,642,819 GPAs. Then you would have to add up all of those GPAs and divide the total by 20,642,819. Assuming you recorded each GPA correctly, that would give you the exact average that you're looking for. But that's probably not possible because you either don't have time to record all of these GPAs, or there's no way for you to contact all college students and ask them for their GPAs, or even if you could, it might be really expensive to do that. So what you would do instead is maybe select a certain number of college students to be your volunteers, maybe a few hundred college students, and record their GPAs. For example, I'll just make up a number right now. Let's say you record the GPAs of 1,000 selected college students who live in the US, and then you calculate the average of those 1,000 people, meaning you add up their 1,000 GPAs and you divide the total by 1,000. After you do that, you'll have the average of your 1,000 volunteers, and you can use that average to estimate the average GPA of all of these college students. Meaning you can use the average of your 1,000 volunteers to at least get a rough idea of what the average GPA of all of these college students would be. And I think I said this, but I'll say it one more time. The average of your 1,000 volunteers is not going to be exactly the same, or it's at least very unlikely to be exactly the same as the average of all of these college students, but it'll at least give you a rough idea of what this average equals. So that's an example of using data recorded from a small group of people to estimate the average GPA of the larger group that they come from. What's another example? Maybe estimating a percentage of a large group of people. Let's use our same example again of all college students in the US. Just to be consistent. So what percentage do we want to estimate? Maybe we're interested in what percentage of college students in the US live with their parents. So maybe we want to know, out of all of these college students in the US, what percentage lives with their parents? If we wanted to actually calculate the exact percentage, we would once again have to record data from every member of this group of people. We would have to ask all of these college students, we'd have to ask each of these college students if he or she lives with his or her parents, and then record all of their answers, and then we could calculate a percentage. But the problem is, we probably can't ask all of these college students whether they live with their parents. So once again, maybe we'll recruit a smaller group of college students, such as maybe 1,000 college students, let's say, and ask them if they live with their parents. And let's say that out of the 1,000 people, out of our 1,000 volunteers, 50% say they live with their parents. So 500 out of our 1,000 volunteers say they live with their parents. That doesn't mean that exactly 50% of all college students in the US live with their parents, meaning that doesn't necessarily mean that, let's see, 20, 6, 4, 2, 19, 19. Just because 500 out of our 1,000 volunteers said they live with their parents doesn't mean that exactly half of all college students in the US live with their parents. But our 50% outcome could at least give us, or could at least hopefully give us, a rough idea of what percentage of all of these college students live with their parents. So once again, we're using data from a small group of college students to estimate something about the larger group that they come from, which in this case is all college students in the US. What's the third purpose of collecting data? The third one we'll talk about is called hypothesis testing, which is using data recorded from a small group. Once again, using data recorded from a small group of people or things to test competing possibilities about a larger group of people or things. What do I mean by competing possibilities? Well, a person might want to know I think this third purpose is the one that is a little bit more difficult to understand at first, but I'll try to give a simple example. A person might want to know, or a person might be interested in whether the average mean or the average GPA of all college students in the US equals 3.0. So once again, we're talking about this number up here of all college students in the US. This time, the person isn't interested in, this time we're not estimating the average, but this time we're trying to make an all or nothing decision about whether we think that the average GPA is equal to 3.0 or if it's some number other than 3.0. So a person might be interested in whether the average GPA, the person might not be interested in estimating the GPA, but the person might just want to make an all or nothing decision about whether the average seems to be 3.0 or if it's not 3.0. And how could the person make that decision? Well, the person could do the same thing we did up here. The person might select a smaller group of people or volunteers and record their GPAs, and based on the GPAs that they end up recording, or based on the GPAs that the person ends up recording, the person will make the decision about these two competing possibilities. And next we'll talk about some more definitions. I think this covers some basic examples. Maybe one more example of this could be a person might be interested in whether well, usually they say that the typical person should get about 8 hours of sleep per night. So a person might be interested in whether the average number of hours slept per night in the US is 8 hours. So a person might be interested in, does the average person in the US get 8 hours of sleep? Or does the average person get a number that's different than 8 hours of sleep, meaning above or below 8 hours of sleep? In that case, the person is interested in two competing possibilities. Possibility one is that the average person in the US gets 8 hours of sleep per night. Possibility two is that the average person doesn't get 8 hours of sleep per night. And the person could record the sleep time. The person could recruit a certain number of volunteers and ask those people how many hours of sleep do you get per night, and the person could use that data to make the decision between those two competing possibilities. So yeah, next we'll talk about a few more definitions. Earlier we talked about the meaning of a data value. Now let's talk about the difference between a data value, a variable, and an observational unit. Those are the three terms that we'll talk about right now. We'll actually talk about them in this order. Well, we've already talked about the meaning of a data value. So next we'll talk about the meaning of an observational unit, and then we'll talk about a variable. So a data value is a piece of information that describes something about a person, animal, thing, or place. And earlier we said that these three things would be our recorded data values: 55 inches, psychology, and 98 inches. The last one was for the height of this tree. And notice that each of these three data values, this one, and this one over here, is describing something. It's either describing a person or a thing. So this 55 inches is describing a person right here. Psychology is describing this person because the person is the psychology major. And 98 inches is describing the height of this tree. So every data value has a person or thing or animal or place that it describes. And there's actually a term for that, which is observational unit. An observational unit is, let me look at my definition. So it's a person, animal, thing, or place about which data is being recorded. So this person right here, and this tree are all observational units. They're all people. Well, in this case, they're people or things that we're recording data about. What if we were recording the height of a dog? So I can't really draw a dog, but I'll just write the word dog right here. And we find out that the dog is 12 inches tall. Well, now 12 inches is a data value, and the observational unit that goes along with this data value is the dog. The dog is the observational unit because the dog is an animal that we're recording data about. We're recording data about the dog, so the dog is the observational unit. And I don't mean that the word dog is an observational unit. I'm meaning that the dog itself is an observational unit. I just had to write the word dog here because I couldn't draw a dog. What if we had a city Um, so we can make up the name of a city, maybe. Or let's say San Jose. I'm not sure exactly how many people live in San Jose, but we'll make up a number. Let's say that 899,313 people live in San Jose. This number isn't correct, but I'm just making it up to explain the idea of what I'm trying to explain. So if this is the population of San Jose, then this number is a data value, and the city of San Jose is an observational unit in this case, because the city of San Jose is a place. So, well, what I'm meaning is, if we decided to record the population of San Jose, and that's the data value that we're recording, then San Jose would be our observational unit, because San Jose is the place that we're recording data about. We're recording data about San Jose, so San Jose is our observational unit. So if you asked one of your friends, what grade did you get on your last exam? The number that the person tells you would be a data value, and your friend would be the observational unit, because when you ask your friend what his or her final exam score was, you're collecting data from your friend, which then makes your friend the observational unit. So we know what an observational unit is. Let's start a new page. Well, first I wanted to say that if you're collecting data from a person, then you actually use a more specific word than observational unit. A person is actually still an observational unit, but more specifically, the person is called a participant, because when that person provides you with data, that person is participating in your survey or participating in your interview. So it's nicer to call the person a participant than just an observational unit. So we'll say that a participant is a human observational unit. And some people might say that an animal could be considered a participant, but we won't get into that right now. There's different guidelines for the names that you should use when you're collecting data from people or from animals, but we won't get into those guidelines. I'm not even sure what the guidelines are for animals exactly. So what if we were let's see, we want to record some data. So what if we record data from the prices of, we record the prices of 5 houses, and we'll call them House 1, House 2, House 3, House 4, and House 5. So we're recording the, what is it? I think I said, oh, the price. So maybe this house is worth $219. this house is worth. I'm just making up these numbers. So we've recorded data from five houses. Now let's say that we're also recording maybe it's just the heights of 5 trees. We'll just stick with that example. Just going to make up some numbers again. So these are the heights of the trees. And we'll do one more example with people. Maybe from the people we want to know. I'm not sure what we were recording. Last time we were recording the heights of the people. Maybe we'll do the ages of 5 people. So we'll say age right here. We'll move this up here. Over here. We'll move this down here. And I think we can move this down here also. We'll see if there's room. Maybe not. So I guess we'll just leave it here for right now. So what are these 5 things right here? These are the data values that have been recorded. They're the pieces of information that describe the houses. So they're the data values. And one thing that I forgot to say is that even if some of the values are repeated, you would still record every value. So even if 2 of these houses had the same price, you would still record both prices. So if house 4 and house 5 were both worth the same amount right here, we would still record that same number 2 times. If tree 1 and tree 2 were both 87 inches, we would still record a height for tree 1 and tree 2. You would just say, we would record 87 inches and then 87 inches again. And we would actually still say that we have 5 data values. Even if 2 of them are repeats, we would still say that we recorded 5 data values because we did record 5 pieces of information. So these are the data values. Now what about the 5 houses? The 5 houses are the observational units. Because they're the things that we're collecting data about. We've collected data from the houses, so the houses are our observational units. We would say the same thing down here. Down here, oh, sorry. Now the heights are our data values. What happened there? The 5 heights are the data values, and the 5 trees are the observational units. Oh, I didn't copy all that. And what about over here? Well, I didn't actually put any ages in there yet. But the 5 ages that we're going to end up putting in here are the data values. The word data value got cut off. Let's see if I can expand this. The 5 ages would be the data values. And what about the people? You would say that these people are sorry, I just have to move this again. The people are the observational units. Person 1 through person 5. And maybe their ages are 25, 32, 47, 62, and 23. So these ages are the data values. The word data value got cut off over here. The people are the observational units, but more specifically, we would call them participants. Because it's a certain type of observational unit. So now we've covered the idea of an observational unit and how it's different from a data value, and we also covered the meaning of a participant. Now let's talk about what a variable means. So first I'm going to erase this example, since I don't think I'll be using it anymore, and I'll move this over here. This would have said data values, but it got cut off. Let's write out the definition of a variable. It's just something that can differ between different people, animals, things, places, or different points in time. So let's try to think of an example of a variable. But actually, I just need 1 second and I'll be right back. So we said that a variable is something that can differ between different people, animals, things, places, or points in time. A variable is just something that isn't always the same. So I think it'll help if we try to think of some examples. What about examples that have to do with people? Age is a variable because different people have different ages. So age is something that can vary across different people. Height is a variable because different people have different heights. What could be another example? College major is a variable because not everyone has the same major in college. Gender is a variable because not everyone is the same gender. So those are all just different things that vary across people. So those would be variables. What about some variables that have to do with animals? Well, height would also be a variable because different animals have different heights. Age would also be a variable, again, just like with people, because different animals have different ages. But what about some variables that have to do with things? So what about different objects? Well, you could say that different things have different colors. Some objects are brown, some are blue, and some are maybe red. So maybe color would be a variable because color varies across different things. For example, different cars have different colors. What's something that varies across different places? Well, different cities have different populations, so population would be a variable. Different cities also have different elevations, so elevation would be a variable. What about different points in time? Well, different points in time. You could say that the temperature outside is different at different points in time, meaning the temperature outside isn't always the same all the time. So you would say that temperature is also a variable. So a variable is just anything that's able to vary. It's not always the same. And when you're first learning about the meaning of a variable, I think it's easy to confuse it with the idea of a data value, and I'll help you separate the idea of a variable from the idea of a data value. First, let's look at some examples involving people. We'll open up a new page. So I said age is a variable because we can see right here that different people are giving us different ages. What if we wanted to record that both the ages and the heights of 5 people? So each person is going to tell us his or her age and his or her height, maybe height in inches. So now we've recorded data from 5 people, meaning 5 participants, because we call them participants and not just observational units because they're people. And we've also, well, we've recorded 10 data values total. The data values are all in here. And we've recorded data with 2 variables. We have 2 variables in our set of recorded data now. So age is a variable, and height is a variable, because these are 2 things that are varying across the people that we're collecting data from. Different people are giving us different ages, and different people are giving us different heights. What if we also wanted to record something else, like the grade level of each person? Let's imagine that we're collecting data from college students, and each person is telling us his or her grade level. If we're collecting data from college students, grade level could be another variable that we use. So maybe one person says that they're a freshman. Maybe the next person says sophomore. Maybe we have a junior, and then another freshman, and then a senior. Now our data set has 3 variables. When I say data set, I just mean the complete set of data that we've recorded has 3 variables. It has age, height, and grade level. And all 3 of these things are things that are able to vary, because different people have different grade levels, different people have different heights, and different people will have different ages. So these 3 things are now the variables. And we can see that all the data that we've ended up recording is starting to look like a spreadsheet in Excel with rows and columns. So you can, if you imagine a spreadsheet with data entered into it, each person is a participant. No, I'm sorry. Each row is a participant, because each row has data from different people. Person one, the data that we recorded from person 1 is here, here, and here, and the data that we recorded from person 2 is here, here, and here. So each row is a different participant, and each cell in the spreadsheet is a data value. So in Excel, this would be a box here, and this would be a box here. So each cell or each box contains a data value, and each column is a variable. So each of the column titles is a different variable. So one way to make the idea of a variable easier to understand or more concrete is to picture it as being the title of a column in the spreadsheet. And if our goal, if the goal of our survey was to record the ages, heights, and grade levels of 5 people, and this was meaning if this was the complete set of data that we wanted to record, then we would say that this is our finished data set. So when a person uses the word data set, they're usually talking about the complete set of data that's been recorded in a certain data collection project. So once all of the data that the person wanted to record has been entered into a spreadsheet or on a piece of paper, then that completed collection of data is usually what's called a data set. So now, what if instead of people, we were recording data from houses again? I said that in this example, each row was a participant, and each column was a variable, and each cell was a data value. But if we weren't recording data from people, meaning if it was house 1, house 2, house 3, then each row would be just an observational unit. So now we're recording data from houses again. Maybe we want to record the price of each house, the size of each house in square feet, and maybe, what's another thing we could record? The number of bedrooms. I'm running out of space. We'll just say number of, maybe, wait, I can, yes. Number of bedrooms would be another variable. We could also, maybe also we want to record the number of floors in each house. So we're recording the prices, the square footage, the number of bedrooms, and the number of floors in 5 houses. So these 5 things up here, these 4 things up here are the variables that are in our data set. These 5 houses are the observational units that we're collecting data from. And how many data values would be in here? 5 times 4. The 20 pieces of information that are in here would be the 20 data values. So, once again, we have columns for variables, rows for participants or observational units, and cells or boxes for data values. And we can also see already that a data value doesn't have to be a number, because right here, freshman is a data value, and over here, 75 is a data value. So data value is just a piece of information. It doesn't have to be a number. It can be a word. Now let's think about, is a column in a spreadsheet, is the title of a column always a variable? Well, a variable has to be something that's able to vary. So what if we wanted to ask each person over here, how many birthdays do you have each year? So number of birthdays is another column in our spreadsheet. Well, no matter how many people we ask, what I'm actually meaning here is how many birthdays do you have each year? No matter how many people we ask, each person will say, I only have 1 birthday each year. Even if we asked 1,000,000 people, we would just get a really long column of ones. So even though number of birthdays would be a column, it's not a variable because it's not something that varies. I think on another spreadsheet I said, not spreadsheet, on another page I said that a variable is something that is able to vary. That's actually where the word variable comes from. It's able to vary. So this isn't a variable. If we asked each person, what planet do you live on, everyone would say Earth. So that also wouldn't be a variable, even though it would be a column in the spreadsheet. So how do we know the difference between a data value and a variable? Well, one way to remember the difference is that the name of the variable is never an answer that a specific person would give you in a survey. So if you asked a person, how old are you? A person would never say, I'm age years old. The reason is because age isn't a data value. It's not a certain person's age. Age is a variable. A person would never say, I'm height inches tall, because height isn't a data value. It's a variable. But a person might say, I'm 75 inches tall. So 75 is a data value because it could be a certain person's height. So the variable is just the idea of what you're measuring or what you're recording. So the idea of age is a variable, and the idea of height is a variable, and the idea or the concept of grade level is a variable. And now we can talk about different types of variables. We can already see here that some variables are giving us numbers and other variables are giving us words. So this variable of height, when you think about the variable of height, each person's data value is a number or an amount. So height would be something called a quantitative variable because each person's height is a number that stands for the amount of something. It stands for a quantity of something. So what is a quantitative variable? Quantitative variable is a variable in which the recorded data values, in which each recorded data value stands for the number of something or the amount of something, meaning a quantity. So actually, each person's age and height are both quantitative variables because each person's age is it's an amount of something. Well, you could think of it as being the number of years that the person has lived, or you could think of it as being the amount of age that the person has. So each person's number is a quantity, meaning you could think of it as the number of something or the amount of something. Each person's age is showing the amount of, each person's height is showing the amount of height that the person has. So height is a variable. And if we were recording number of children, then that would also be a quantitative variable because each data value would be either the number of something or the amount of something. What about income? Income is quantitative because each person's income would be the amount of income that the person is earning. So basically, whenever each data value stands for either the number of something, such as the number of children or the number of TVs a person owns, or the amount of something, like the amount of height that a person has, or the amount of well, I said height, the amount of height or the amount of age, then those things would all be quantitative variables. So we have two quantitative variables. What about over here? When we were recording things about houses, the number of bedrooms is a quantitative variable because each data value is the number of something. The number of floors is quantitative. Price is quantitative. Square feet is also quantitative. So what about something that's not quantitative? The opposite is a qualitative variable. Or sometimes it's also called a categorical variable, which is a variable in which each recorded data value puts something, puts a person, animal, or thing into a certain category. What if we were recording, well, grade level, when you think about grade level, each person's data value is actually a category. It's not actually a number of something. So this would actually be qualitative. And it's a little bit tricky because you might think that a person who's a freshman has been in college for 1 year, and a person who's a sophomore has been in college for 2 years. But we're not actually recording the number of years in college. We're just recording a category that a person is a member of. So its grade level is actually qualitative. What about college major? If we were asking each person, what's your major in college? That would be qualitative. Because if a person says psychology or business, then these answers, or these data values such as psychology and business, don't show the number of something or the amount of something. They just put the person into a certain category. This just shows that the person is a member of the category of psychology majors. This person is a member of business majors. So it's actually qualitative. Now it might be easy, or it would be nice if, well, so far we have two quantitative variables right here, and we have two qualitative variables. But it would be nice if data values with numbers were always went along with quantitative variables, and data values that are words always went along with qualitative variables. But unfortunately, it's not that simple, because some numbers don't actually stand for a number or amount of something. So what about if we asked each person, what's your social security number? That would be a variable because different people have different social security numbers, but it's actually not quantitative, because a person's social security number doesn't show the number of something or the amount of something that the person has. It's just a label, or it's sort of like another name for the person. So you could think of it as just being a category of one person, pretty much. It's not something like over here where each data value is showing the amount of height that the person has. It's not. The social security number isn't a quantity. What if we asked each person, what if we were collecting data from sports players and we said, what's your jersey number? If a person tells us that their jersey number is 17, that's not the amount of anything. It doesn't mean that the person has made 17 home runs, or that the person has scored 17 touchdowns. It doesn't stand for the number or amount of anything. Once again, it's just a category of one person. Driver's license numbers also wouldn't be quantitative. That's also just a category. A person's driver's license number is, again, just a category that one person fits into. So these two are quantitative. And if we had income or weight, those would also be quantitative. But these three over here are actually qualitative, just like how grade level and college major are qualitative. Whenever you have variables that just deal with labels, or numbers that are really just labels for people or things, then those variables are actually qualitative. Also, so quantitative means numbers that actually stand for a quantity, and qualitative means the data values are either words, like over here, or meaningless numbers that are just labels. I mean, numbers that don't. What I mean by meaningless is just numbers that don't actually stand for amounts. We can actually break. The last thing we'll do is that we'll break these down into two other types of variables. So I said that we can have quantitative variables. Quantitative variables can be discrete variables, or they can be continuous variables. So what's a discrete variable? It's a variable in which there are gaps between the possible data values. So what do I mean by this? If you ask a person, how many children do you have? We'll use that as our first example. person might say, I have one or one child, or maybe two children, or maybe three children, but they'll never say anything in between. A person will never say, I have 2.5 children, or I have 2.7 children, and they'll never say, I have 1.3 children. So in between these possible data values, there are gaps where you'll never find a person, or I mean, where you'll never find a data value. You'll never find a person who has a number of children between 0 and 1. You'll never find a person with a number of children between 1 and 2, or between 1 and 3. So what I'm showing here are gaps in the number line. The red places are gaps where you don't have any data values. And in green, I'm showing where the data values are. I mean, where the possible data values are. What could be another example? Well, what if you ask people, what's your shoe size? A person can have a shoe size of, let's just start at 10, maybe 10, 10.5, 11, 11.5, and 12. So here we have gaps in the number line again. A person will never have a shoe size between 10 and 10.5. A person will never have a shoe size between 10.5 and 11. For example, a person will never have a shoe size, at least that I know of 10.7, or a person will never have a shoe size of 10.3 because they don't make shoes with those sizes. So these green points are where the possible values are, the possible data values. And we'll talk about a couple more examples. If you ask each person, if you're asking people, how much milk do you buy each time you go to the store? A person might say, I buy 10 gallons of milk, or I buy 10.5 gallons of milk, or a person, if you buy a small container, a person could maybe say, well, I think they maybe sell quarter gallons. So if you bought a full gallon and a quarter gallon, I guess you could buy 1.25 gallons of milk. But there are gaps between the possible values because a person might never be able to buy 10.8 a person might never be able to buy 1.8 gallons of milk. So that might also be discrete. Anything that deals with amounts of money is also discrete because let's maybe say account amount of money spent on gas per week. That's what we're asking people now. A person, what are the possible data values? Well, you could have what should be our starting point? Let's start with $0. I think that's a good starting point. A person could spend 0. If a person wanted to, a person could spend 0.01 gallons. I'm sorry. If a person wanted to, a person could spend 1 cent on gas per week. A person could spend 2 cents. It doesn't really make sense, but it's possible. Or 3 cents. But a person wouldn't be able to spend let's see. I don't think a person would be able to spend 0.015 cents. Or I don't think a person would be able to spend this amount of money on gas per week, because I don't think this wouldn't be a possible amount of money that could be spent, because there's no coin that's smaller than a penny. So, let's see. You wouldn't have any data values in here, and you wouldn't have any possible data values in here, or any possible data values in here. The possible values or the possible answers that we would get would jump from this. They jump from here to here to here to here. Amount of money spent on anything like amount of money spent on food per week would also work the same way. So these are discrete variables. What's the opposite of a discrete variable? The opposite is something that's continuous, where there's no gaps in the number line. In which there are no gaps between the possible data values. Let's look back at our examples of age and height. What would happen if we tried to draw a number line and to mark off the possible height, the possible ages that a person could have? And we're not talking about age the way we usually think of age, which is just a whole number, but we're thinking about the exact age that a person is right at this moment. And what if we tried to mark off the exact ages that a person could be right at this moment? And we're trying to figure out where the gaps are. What if we tried to figure out where are the gaps that a person's exact age could never be? Now, let's think about, is there a gap between 1 and 2? For example, could a person be 1.5 years old? Well, a person can be. A person could also be 1.6 years old right now. What about something Well, now let's think, is there a gap between 1.5 and 1.6? Well, there is no gap because a person could be 1.55 years old right now. That could be an exact age. So, and if we looked at these two possible exact ages, 1.55 and 1.56, there's also no gap between these two values, because at this moment a person could be 1.557 years old. So really, when you think about the exact age of a person, the exact age of a person could be anywhere on this number line, meaning there are no red places. A person's exact age could be anywhere, so it's all green. It's all possible. So when you think of the word continuous, you can think that the number line of possible values continues with no gaps in it. Height would be the same way. A person's exact height could be anywhere on a number line. There are no gaps where you find an area where a person could never have this height. So age and height would both be considered continuous. A lot of naturally occurring amounts are continuous, like amounts of rainfall or wind speeds and things like that, or heights of people. Often what makes something discrete is something when only whole numbers are possible. Like some things are only created in whole amounts, like people are always whole amounts. You never have half of a person, and things like TVs are always whole. You don't find half of the TV. Also, shoe sizes are only created in certain amounts or certain sizes. So often what makes something discrete is when things are only created in certain sizes. So let's now talk about the two different types of qualitative. That's the last thing we'll talk about. So qualitative or categorical variable can be nominal or ordinal. So what is a nominal variable? Well, first let's define an ordinal variable. An ordinal variable is a qualitative or categorical variable in which the possible categories follow an order from lowest to highest, meaning they follow a hierarchy from lowest to highest. Now, what are some examples? Well, something like we talked about. We could start with some examples that have to do with people. Grade level is an ordinal variable because what are the possible grade levels? You have Will Eastman College, freshman, sophomore, junior, and senior. The possible categories follow in order from lowest to highest. So it's an ordinal variable. Socioeconomic status. What are the possible categories? The ones you usually hear about are lower, middle, and upper class. So that's socioeconomic status is an ordinal variable, just like how grade level is an ordinal variable. We talked about how age is quantitative, but sometimes people talk about ages as being age groups or age categories. So when you think about age group, and you have categories like child, adolescent, and adult, now age group is actually an ordinal variable. Age in years is quantitative, but age group is ordinal. When you think about people's achievement in the Olympics, you have bronze medal winners, then you have silver medal winners, and you have gold medal winners. So achievement in the Olympics would also be ordinal. In management, you have lower, middle, and upper managers. So manager status would be ordinal. In universities, you have professors who have different statuses. You have assistant, associate, and full professors. So the status of professors would also be ordinal. But one thing you have to remember is that when a variable is ordinal, it doesn't necessarily mean that higher categories are better than lower categories. For example, you might be able to put people into categories based on where they live. Like, well, right here, it's obviously not better to be a senior than to be a freshman. It's not. So let's see right here. One important thing to remember about ordinal variables is that it doesn't have to be a series of ranks that a person passes through from. It doesn't have to be a series of ranks that a person passes through from beginning to end, because right here a person has to start as a freshman and then work their way up to a senior. And when I talked about professor statuses or manager statuses, those are also a series of ranks that people pass through in order. But it doesn't have to be that way to be an ordinal variable, because a person, when you think about the Olympics example, a person could win a gold medal without ever having won a bronze or a silver first. So that's one thing to remember. So if you want some examples that don't have to do with people, you could think of cup sizes. The typical cup sizes are small, medium, and large. So cup size would be an ordinal variable. You have different types of coins, such as pennies, nickels, dimes, and then quarters, and those follow an order from lowest to highest. So that would be types of coins would be an ordinal variable. You have different hotness, the spiciness or hotness of different salsas would be ordinal, because you might have mild, medium, and then hot salsa. So what is the opposite? Well, two other examples could be, well, actually, we won't do any more examples of ordinal variables. So a nominal variable is a qualitative variable in which the categories don't follow an order from lowest to highest. So it's basically whenever there isn't an order, it becomes a nominal variable. They do not follow an order from lowest to highest. So what could be an example of a nominal variable? Well, college major would be nominal because college majors don't follow an order from lowest to highest. For example, a business major wouldn't be above a psychology major, and a psychology major wouldn't be above a business major. All college majors are considered to be equal, so it would be nominal. Also, the variable of handedness, which means left-handed and right-handed variable. Sorry, what did I say? Left-handed and right-handed people would also that would also be a nominal variable, because when you think about left-handed and right-handed people, neither of those two categories is above the other category, so they don't follow an order from lowest to highest. So examples of nominal variables. I said college major, handedness, which means the categories are left-handed and right-handed people. What about favorite sport? People's, well, you have football fans, basketball fans, or soccer fans, or hockey fans. Those categories don't follow an order from lowest to highest, so that would be a nominal variable, just like college major and handedness. You also have different learning styles. Some people have different learning styles. Like some people are visual learners, and some people are auditory learners. And those categories don't follow an order from lowest to highest. All categories are equal. Also, people, what could be another example? Well, different types of pet owners. You have dog owners, cat owners, and maybe people who own hamsters or turtles. Those categories don't follow any type of order from lowest to highest. Different types of if you want an example that has to do with people, maybe different types of cars, like black cars, red cars, yellow cars. I don't think those categories follow an order from lowest to highest, so it would be nominal. different types of cereal, such as Cheerios, shredded wheat, that would be a nominal variable because all the different types of cereal don't follow an order from lowest to highest. So a nominal variable is just when the possible categories don't follow any order from lowest to highest. If all categories are considered to be equal, it's a nominal variable. And thank you for watching.